Hello, Algebra 2. Um, Chapter 2.5, as you know, talks about best fitting lines and correlation. And as I mentioned, I'm going to cover this in two different forms because we have to be able to do it by hand and we also have to be able to do it with the graphing calculator. This video lesson will just focus on the first part, doing this by hand, and there are 4 skills that you need to be able to perform. I assume that most of you have done this many times, so I'm going to go through this fairly quickly. Step 1, being able to draw a scatter plot from some data. Step 2, being able to come up with your own best fitting line that truly is reasonable in terms of representing the data that you've put on the graph. And then 3, being able to come up with the equation of that line you've drawn. And lastly, step 4, being able to use the line that you've drawn and extending it longer if necessary to identify a value that would be on the line, whether that's something in the midst actually of the data that you have but not actually represented by a point, or something that would be further to the left and lower or further to the right and higher on a growth graph. So the story that we're going to work from is this one about Benny selling water bottles from his hot dog cart in Boston. And as I've probably mentioned in class already to you, the basic concept here is that Benny has been keeping track of the temperature outside and comparing that to the number of water bottles that he's sold, and he believes there's some relationship between the two, and so he's trying to figure out exactly what that relationship is and how strong that relationship is, that correlation is. But step 1 for him, if he's going to graph this, is to figure out which of the two sets of data is the x, or in other words, the independent values, and which is the y, or the dependent values. And hopefully you can see that temperature is the independent, y is the dependent. So I've superimposed a grid on top of the data here. I know it makes it a little bit tough to read, but it helps me to figure out where to place my points. So as you can see, I've got a broken graph here that represents bottles on the y-axis. The first value shown being 100 and climbing to 260 bottles. And along the x-axis here, the independent values goes all the way from temperature of 0 up to temperature of 100. The first data point is 71,133, and I've placed that here. And there's the second, there's the third. And you can see this is going to be hard to read, so let's just skip ahead from this and see how the textbook drew the scatter plot. Looks like this, and then, as I've said, the next step is to try to fit a best fit line to that. Here is my effort at that. Keep in mind that the task here is not necessarily to have it ever go through any particular point, but instead do the best job of representing the general trend of all the points. So sometimes your best fit line won't go through any of the individuals. In order to come up with an equation, I've got to extend that line long enough that I can confidently state the slope and the y-intercept, or 2 points, as we've talked about before, and be able to calculate the equation from 2 points. Well, I'm suggesting here that the y-intercept is roughly at 100, but that's pretty rough, and that the slope, well, I'm going from, there isn't any place on here that I see that it clearly goes through crosshairs. So I'm simply going to calculate slope from this point here to that point there. My rough estimate, again, is that the rise is 78 and the run is 22. Based on that, I would say that the equation is about 78 over 22 for the slope x plus, well, I ended up deciding maybe it's not exactly 100, and I guesstimated 99. But then for each of these, I said, is it so bad if I round them? It really isn't, to come up with a rough equation. And so I've rounded each of these numbers, and now I've got that as my equation, 80 over 20 becoming a slope of 4. And I'm saying that my equation is 4x plus 100, keeping in mind that that's rough, but then again, so was my best fit line. Well, if I wanted to use that, or Benny, I thought his name was Benny originally, but here he is, Bernie. If Bernie or Benny wanted to use that equation to make a confident estimate of how many water bottles he should pack on a day when it's 77 degrees, he needs to have a pretty reliable and trustworthy equation. And that brings us to the next step in this lesson, and actually a separate video, which is to compare the information that we have by hand with what we get from a graphing calculator. The final step, if you're doing it by hand, is simply to plug that 77 degrees in here for x and to calculate based on 4 times 77 plus 100 how many water bottles he should bring. But let's compare that in a separate video with what we get from a graphing calculator. I'm sorry, I forgot that I did have one more slide, and here I've tried to represent the result I got from doing it by hand. I've indicated here that this is roughly where I'm saying 77 degrees is, and it looks to me like it's about 160 water bottles. So that'll be something that you'll actually end up comparing to your own hand-drawn graph and also your own result when you enter this data into the graphing calculator.